Hello everyone, welcome to the code space. In this video, we are going to learn about the Fenwick tree algorithm. We already learned about the prefix tree algorithm, which basically use it for obtaining the range queries. The Fenwick tree is also used for the range queries. Then, what is the specialty about this Fenwick tree? If we consider a prefix, let's say we have an array 1, 2, 3, and 4, 5, and we maintain a prefix for this array. Then the first value of that prefix will be 1 and then 3 and then 6 and then 10 and at the last it will be 15. Now the drawback or the limitation in the prefix is if you want to maintain any element of the array, if we can alter the element or we can increase or decrease the element, then to obtain the correct prefix we have to change the entire prefix, which actually taking the order of n time. So in prefix, updation will actually take order of n, but we can optimize this updation by using Fenwick tree. Updation can be done in log of n time period. So in this, basically we divide the prefix array. We'll divide that and we'll maintain like an entire array which is a multiple of 2. First, we'll consider an entire array of 2 power 0, which is 1. We'll consider this as a whole. Like if we take this, if we take the same array 1, 2, 3, 4, 5, then in Fenwick tree we'll maintain a continuous block from for the 0 element and the next from 0 element to the 0 to first element, that is nothing but 2 power 1, which is 2, and again we'll maintain a complete from 0 to the third element at this position, and for the at this position we'll maintain from 0 to from the starting point is from element 2 to element ending point is also the element 2, and then for fifth element also will maintain only for the fifth element. So the prefix tree of this array is going to be somewhat 1, and then we'll store here 3, and then we'll store 3, and then 7, and then 5. So in this way we'll maintain the, like here it should be 10, as we are maintaining the total sum from 0th element to that element 4. So the total sum will be 10, and here we'll maintain the only index 5. So by maintaining this, we have an advantage. We have an advantage in updating the element array. So we have learned that in the prefix algorithm we can only apply the range from L to R only if the operator is invertible. Similarly, in Fenwick tree also this condition still be held by the operator. In Fenwick tree also the operator must be invertible for L to R queries. For general queries, the operator must be invertible. And if the operator is not invertible, then still you can use the Fenwick tree for the queries starting with 0. If not, still you can use for 0 to L queries or 0 to R queries. Okay, this is all about the Fenwick tree algorithm. Let's see the implementation of Fenwick tree algorithm. First of all, let's write the simple code for this. We'll write the will include the standard library bit slash std c++.h, then single namespace std. So let's start with the main. I'll just write the simple, implement the update and query function of the segment tree. Let's suppose we have an array bit which is already initialized in the main. So we just have to write the two functions. One is void update and the other one is void in query. So the update function is used to update an element uh, from the array. And I just want to say about one thing that can't be used can't be used for range updates. Like if there is an update, you have to perform an update from L to R. Like we have to sum up all the elements in the array from L to R. Then we can't use this segment tree. We can have to go to the like we can't use this Fenwick tree. We have to go with segment tree. Now, so there is only one type of update we are going to apply on this Fenwick tree, in which we'll take an ID and another value val. We are going to add this val to that element in present at the ID. So we'll run a while loop while ID is less than n, where n is the size of the Fenwick tree. Every time we add a lost set bit to that same ID, therefore the ID is equal to ID plus ID ampersand ID minus 1 will actually give the last ID of that number. So we are just going to add that to the same ID which will update, which will add the last set bit to that same value. And every time we'll update our Fenwick tree BIT of ID plus equal to val, which will actually update the Fenwick tree with val. So this is all about the update. Inquiry will take an IDR. This will return actually gives the result from L to R. Here we'll take a simple variable ID, which in this case this will return from 0 to ID. So first here we'll start with a variable ID in ns. We'll start with ns and we'll run a while loop. Start with of ID. Or you can also start with 0. In this case, if you're considering sum, then you can start with 0. And then every time we'll add the value present at ID, and I will decrement this time will decrement the value of the ID by its last set bit, which in this case will give ID ampersand ID minus 1. This time we'll use a subtraction symbol. Here we use the plus symbol. Here we'll use subtraction symbol. So this is all about the update function and the query function in the Fenwick tree. I hope you get a clear idea, and this is not a big task to be implement for the implement also. It is a bit difficult to implement a segment tree, which we are going to see about in the in the next section. And I hope you have understood and got a clear idea on Fenwick tree. If you like this video, hit the like button and thank you for watching.